Hi, I'm Andy Lechner here with R&W Couplings at MD&M ATX West with a brief design tip about torsional stiffness and flexibility in stainless steel bellows couplings. Bellows couplings are generally employed for their very high torsion resistance. Constructed from a tube of stainless steel hydroformed to include deep corrugations allowing for lateral flexibility, the bellows still maintains the stiffness inherent to a tubular structure with a relatively large outside diameter. Shown here are three different levels of torsional stiffness, illustrating the trade-offs between misalignment compensation and the stiffness itself. Torsional stiffness is important in positioning systems where load must be positioned in exactly the right place at exactly the right time, and where multiple axes must be synchronized in motion and under various load conditions. Coupling stiffness generally affects the overall stability of a motion system. Being the most compliant of components in the system, it can dictate the mechanical resonant frequency of the system overall. In cases where resonance can be problematic, where the torsional stiffness of any given coupling allows the mechanical resonant frequency to match up with the frequency of the drive, vibration may result. This can be combated by elevating the torsional stiffness of the coupling, though alignment must be addressed. Shown here in the chart on the left is a comparison of torsional stiffness between the three coupling types. All three are relatively very high compared to comparable highly rigid couplings. On the right-hand side is an illustration of the trade-offs in lateral flexibility. When torsional stiffness must be elevated, alignment issues must be addressed. The coupling on the right-hand side, while still exhibiting a relatively very high stiffness, also can compensate for a large amount of lateral misalignment. Lateral misalignment compensation ability is multiplied rather than doubled with a double flex coupling. The lateral misalignment which can be compensated is a function of the tangent of the angular flexibility of each bellows multiplied by the distance between the center of each, and this rule can be applied to all couplings. A low-cost, robust, and available alternative to torsionally rigid couplings are vibration damping couplings. So-called servo insert couplings have a preloaded insert to allow for a high level of repeatability with zero backlash. Vibration damping is accomplished through the torsional flexibility of the insert itself. Thanks for visiting us at ATX MD&M West. For more information on R&W couplings, contact us at rw-america.com. And feel free to request a copy of our free book, Precision Couplings and Line Shafts, for information on sizing for torsional stiffness, resonant frequency, and much more.